Okay, for 7.3, we're going to talk about double angle and half angle. So basically, what we mean by double angle, we're going to have some formula for if we double something, what is it going to equal? And if we half something, what's it going to equal? Okay, so first, let's do the one for sine. So we already have the formula for the sum is sine of x cosine of y plus cosine of x sine of y. Okay, if I make those the same angle, x plus x, that would give me my double angle. Okay, so let's see what that does. This gives me sine of x cosine of x plus cosine of x sine of x, which gives me 2 sine of x cosine of x. Same thing. Okay, so there is my double angle formula for sine. Now, to do the cosine, I'm going to do the same thing. Cosine of x plus x. Use my sum formula, which told me that I have cosine of x minus sine of x sine of x, which is going to be cosine squared x minus sine squared x. Okay? So there's my form. Oops, that's not supposed to be squared. There's my double angle formula for cosine. Okay? Another way of thinking about it is we can change that cosine to 1 minus sine like I did in the last section. There's just two ways of thinking about it. Which gives you 1 minus 2 sine squared x. Just a different way if you wanted to use that. Okay? And similarly, with tan, you can have 3 different things. I'm not going to go through all of them. You can have 3 different things by doing that replacement. You can have 2 tan of x over 1 minus tan squared of x. You can have 2 cotan of x over cotan squared, not cosine, cotan squared of x minus 1. Or you can have 2 over cotan of x minus tan of x. All 3 are equivalent. You can all use the same thing. Okay? Now, for the half angle, that would be something like you have an angle divided by 2. What is it going to be equal to? Now, let's start with my cosine. Let's take my double angle for cosine. Cosine of 2x. Well, let's use a different letter. Let's say 2n. That is equal to 1 minus 2 sine squared n. Okay? Now, let's say that n is equal to some half angle. That means 2n is equal to just x. Okay, so if I make that substitution, that's going to say cosine of x is equal to 1 minus 2 times sine squared of x over 2. Okay? If I move these guys around, swap these two guys around, that's going to give me sine squared of x over 2 equals 1 minus cosine of x, and then I'll divide by that 2, and it gives me that. So then, to make it sine of x over 2, which is what we're shooting for, we just take the square root. And we always need to take plus or minus the square root of that. So that's my half angle formula. Now, if you do it in a similar manner, using the sine double angle, you'll get the cosine half angle, and it gives you plus or minus the square root of 1 plus cosine of x all over 2. Okay? Now, your tangent of x over 2, it can be used using these two formulas I just came up with. Quotient says use this, because it says I can change this. I just found sine to be plus or minus the square root of 1 minus cosine of x all over 2 over the square root of 1 plus cosine of x all over 2. Okay? Combine those together into one square root. The 2's can cancel, and I'm left with, this is the half angle for tan. 1 minus cosine of x, square root of that, all over 1 plus cosine of x. Okay, now there's two more different versions of that. You can also change some things around and make that sine of x over 1 plus cosine of x, or you can do 1 minus cosine of x over sine of x. They're all this equivalent things. It's just you can move stuff around like I've been moving everything around using identities. Now these are going to be handy for solving. This is what we're all working to. We're working up all these different identities for solving different equations, which is ultimately what this chapter is about. So next section we're going to talk about some more identities.